Welcome to cs1104 Computer Systems. This is the Unit 1 lecture and a special lecture about how to use Logism. So one of the tools that we're going to be using in this course is called Logism. And essentially it's a logical circuit simulator, hence the name Logism. And essentially what this allows us to do is it allows us to graphically design logic circuits and then emulate their activity. Now we're actually going to use this tool instead of the hardware simulator tool that comes in the TECS set, simply because I think that the graphical ability to see and design these circuits really kind of helps us in understanding how they're functioning. So what we're going to do is just show you how to do the first unit's assignment and give you some pointers around the use of Logism. So this is the main screen of Logism. I downloaded it, I went out and installed it, and so now I basically have my Logism up, and you'll notice I have a series of menu items off to the left hand side. There's different things that I can actually use. What I'm going to be using today primarily is the gates, because what we want to do in the Unit 1 assignment is we want to actually take all of the different gates in here, emulate them so that we get an understanding of what their characteristics are. And the one that I'm going to actually show you is the NAND gate. So the way that I'm going to do this is I'm going to click on the NAND gate, and then you'll notice that I kind of drag it with me. It's under my cursor, and then I can just kind of drop it in the space. The other thing I want to do is I want to select a pin. So this is a pin up here, and basically a pin in Logism is something where I can actually set a value in it. Now keep in mind we're talking about logic circuits, so the only values we ever have is 0 and 1, and it represents a voltage of 0 or a positive voltage when it's 1. So when it's 0, that means no voltage. When it's 1, it means that there is a voltage in the circuit. We've all kind of gone through at this point in time, hopefully, the section that we had on transistors. So we understand that these are just simply functioning as switches, using transistors to turn those switches on and off to allow or not allow the flow of electricity through the circuit. So I'm basically going to have two pins. The reason I want to do that is that a NAND gate actually has two inputs, and it's going to make a decision between those two inputs based upon its truth table. I also have this round pin symbol, which is an output. So that's going to tell me what the output coming out of the gate is. And then I've basically put all of the items that I need on the page at this point in time to simulate this particular gate and to simulate its operation. All I need to do is wire it up right now. Now, notice how I have this arrow symbol selected. When it's in the arrow symbol, it means that I'm actually in a construct phase. It allows me to do the wiring and development of the circuit. When I click on this symbol over here, which is the little red hand, essentially it puts me into the simulation phase. So I'm actually not going to be able to edit this circuit any longer, but I'm actually going to be able to test its operation, because it'll be simulating the activity of the circuit. So what I'm going to do right now is I'm going to have the arrow selected, and once I have the arrow selected, I'm actually going to wire the circuit. So all I do is I simply click on the component, I drag a wire across, and I'm just going to drag it right into my NAND gate. And I'm going to do that for the other side as well. So essentially this means I am creating A and B, or X and Y, whatever designation you want to have, inputs into the NAND gate. And then I want to have an output that's going to come out of there to the pin that I have out here. Now, one of the things you're going to notice is that it instantly went and turned green, and I have a number 1 on here. Now, the reason why that happened is if you go look at the truth table on the NAND gate, we know that the NAND gate is going to have a value of 1 unless both of the inputs have a value of 1. So if either of the inputs are 0, then this will have a value of 1, which means it's essentially the exact opposite of the AND gate. And in fact, you know what? I'm going to put the AND gate real briefly here. We're going to do the exact same thing where we're going to put some inputs on here just so that we can see what the difference is between these two different gates. And I'm going to try to do it rather quickly here so we can not waste a lot of time. So here we notice that the AND gate has a value of 0. Now I'm going to click this into the simulation mode, and you notice that on the NAND gate, or not AND, its operation is exactly opposite of the AND gate. So for example, if I If I click a 1 here, it doesn't change. Again, if I click the 1 here, it doesn't change. And the reason why it's an AND, it means that both of the inputs must have a value of 1 in order for the state to change. So let's do that. Let's change both the inputs. And notice here when I change both the inputs, again, an AND or not AND, the value actually changes, and the same thing's going to happen here. But we can see the behavior between the AND the NAND is exactly opposite, where the NAND, by default, if my condition is not met, is going to have a value of 1. The AND, if my condition is not met, has a value of 0. And then when my condition is met, which means both inputs must be a 1, the state changes. If either one of them is a 0, if you notice how I'm changing this, if either one of them is a 0, because it is in fact an AND operation, the state does not change. And I can see that same kind of behavior here. If either one of them is 0, the state is not going to change, it's going to remain 1. But when both of them become 1, let me just do that, then the state is actually going to change. And hopefully this gives you a sense of how to use Logism and a way to kind of use it to really kind of get a sense for how these gates are functioning, to view their properties, to play with the inputs and see what the outputs are. One of the other things I want to tell you is that in subsequent exercises, we're going to have to go through the process of being able to connect these together. And essentially that works the exact same way. If I needed to connect these two particular gates together, I might want to just simply wire them together. So essentially I can wire different gates together in the exact same manner that I am in simulating, and then I can simulate this entire circuit.